Aloha everybody, this is Gigi from Kauai Community College. In this video, we will take a look at the difference quotient. The definition. We will use this graphical presentation here to explain what a difference quotient is. Suppose you have a function f of x, okay? And we are going to have the point here called x, f of x. And this second point here would be x plus h, comma, f of x plus h. And that are 2 points in the on the curve f of x, right? Now, given 2 points, we can connect the 2 dots and get the blue line. We call that blue line the secant line because it crosses the curve twice, or more than once at this point. Okay, so that secant line has a slope. We are interested in the slope of that secant line. Okay, now when we're looking at the slope of the secant line, we are looking at the change in y over change in x, and that is also being defined as the average rate of change of a function. And that would be y2 minus y1 over x2 minus x1. So we have the y2 minus y1, that's the difference in y. And then x2 minus x1, that would be the difference in x. And in this case, the difference would just be h. So the difference quotient is defined as what we call the slope of the secant line, or the average rate of change. And that is f of x plus h, that would be change in y, over h, and that would be our change in x. Now, why are we interested in the difference quotient? Because later in calculus, we are going to use this concept to find the slope of the tangent line, or the instantaneous rate of change. For now, in an algebra class, you are expected to use the concept of function, input, output, and algebra of function to be able to simplify the difference quotient. Here is an example. F of x equals to x squared minus 5x plus 2. The difference quotient is f of x plus h minus f of x all over h. That would be change in y over change in x. For f of x plus h is our input. So wherever we see x, we will substitute that with x plus h. So we have x plus h squared minus 5 times x plus h plus 2. F of x is the entire function here, okay, all divided by h. So you are expected in this class to just simplify to get the difference quotient. X plus h squared is a binomial square. That would be x squared plus 2xh plus h squared. Distribute the negative 5, we will have negative 5x minus 5h plus 2. And that is the expression for f of x plus h minus x squared plus 5x minus 2 when we distribute the negative, all divided by h. So as you can see here, you have things that going to be able to cancel out, like positive x squared minus x squared, that's gone. Negative 5x squared plus 5x squared, that's 0. Positive 2 minus 2, that is 0. All you end up with now is 2xh plus h squared minus 5h all divided by h. And I said all divided by h. So if I just go ahead and divide every term by h, I will have 2x plus h squared divided by h is just h. And 5h divided by h is just 5. So I will have minus 5 here. And that is the difference quotient for the function f of x equals to x squared minus 5x plus 2. Okay, so just algebra, substitution, input, output with functions. Here's another example. F of x is the function 1 over x. The difference quotient, f of x plus h minus f of x over h, is going to be, wherever I see x, I plug in x plus h. So I will have 1 over x plus h minus the function itself, which is 1 over x, all divided by the difference in x, which would just be h. Now, how do we simplify such a complicated fraction? Actually, the word for it is a complex fraction. So how do we simplify a complex fraction? We multiply by 1. What is the 1? We have denominators as you know, least common denominator. We'll get rid of all of these all at once. So I'm going to multiply this complex fraction by 1, and that 1 is going to be least common denominator divided by least common denominator, right? So when distribute, the x plus h in the red term there is going to cancel out. That will just give me x. The second term, the x value in the denominator, will get canceled out when I distribute that value there. And I will have x plus h all over h multiplied by this, right? Multiply straight across. And here I get to distribute that into each term there. Okay. Distribute the negative. X minus x is gone. Divided by h. And I have the difference quotient being negative 1 over x times x plus h. That is some fancy algebra for you. And that is it for the difference quotient.